Hello families, today I'm gonna start a series of presentation about trigonometric functions. I will start by defining the trigonometric functions sine and cosine. Those functions are defined in different ways, but I will focus on their geometrical meaning based on a unit circle. Okay, first let's take in the rectangular coordinate system, let's have initial side, the positive x-axis, and its terminal side is the arrow that forms the angle theta. The terminal side intersects the unit circle at the point x, y. So our definition for trigonometric function sine and cosine. X is cosine of the angle theta and y is sine of theta. If we take an angle theta, another angle, where the terminal side is in the second quadrant, that intersects the unit circle at the point x, y. First coordinate x, second coordinate y. So the cosine of the angle theta is x and the sine of the angle theta is y. This is our definition for the trigonometric function cosine and sine. Okay, look, in the first quadrant, second quadrant, in the third quadrant, wherever our trigonometric function definition, the sine function and the cosine function definition is the first coordinate and the second coordinate respectively. Now you have to focus. Our angle measurement, initial side is the positive x-axis and the terminal side is our row that intersect the unit circle at the point x, y. So terminal side of the angle is whether it's in the first quadrant, in the second quadrant, in the third quadrant, in the fourth quadrant. The angle theta, its cosine and sine values x and y respectively. That's the geometrical definition of sine and cosine. That's all. Now, after we understand what we mean cosine of an angle, sine of an angle, then we need to generalize what we know about its geometrical meaning based on right angle triangle. X is cos theta and y is sine theta. Let's consider a right angle triangle ABC. In this right angle triangle, let's take the side AB, AC and BC as you see in the graphical representation. Now we need to sketch a unit circle centered at A and consider AC on the x-axis. By forming a coordinate system on this plane, the x-axis overlap over AC and the origin is at A. And then take the unit circle which is in blue. Okay, now from our previous definition we know that the side AC is our initial side for angle theta and side AB is our so the terminal side AB intersects the unit circle at the point E. So that point, that's x, y. That means the side AD, let's represent the point, those points by D and E. So the side AD is x and DE is y. So from what we defined before, we know that DE is sine theta, that is y, and AD is cos theta, that is x. Now right angle triangle in this diagram, triangle ABC and triangle AED. So angle theta is common angle for the two right angle triangle and we have 90 degrees for both. The remaining angles of triangle AED and ABC are congruent. So from this we get that the triangle ADE and triangle ACB are similar by angle similarity. Okay, we have similar triangle. So we know from similarity the corresponding side ratios are equal. So side CB over side DE is equal to side AB over side AE. And we have the results that side CB is A, is given. Side DE is sine theta we know from the previous definition what we have defined using units circle, and AB is C, that's given, and AE is the radius of the unit circle that we construct, that is 1. So sine A over sine theta is equal to C over 1. Then we rearrange and we get sine theta is equal to A over C. What's A? Opposite to the angle theta. What is C? Hypotenuse to the angle theta in the right angle triangle ABC. Similarly, the other side ratio, corresponding side ratio, AC over AD is equal to AB over AE. Let us substitute their value. AC means A, AD means cos theta from the definition over unit circle, and AB is the side C, and AE is 1, the radius of the unit circle. So when we rearrange, we will get cos theta is equal to B over C.